Hello, everyone, and welcome to today's ASCE webinar, How Boise State University Provides Engineering Students with Remote Access to Applications and Desktops. This webinar is brought to you by Amazon Web Services in partnership with ASCE. To find all ASCE webinars, including this one, visit the ASCE course catalog at the link on your screen. My name is Alex Sharp, and I'll be hosting today's webinar. Before we begin, I'd like to go over a few housekeeping items. You can connect with ASCE and with each other by sending messages in the chat pod. So if anyone would like to test that out right now, please go ahead. After the webinar ends, please check your email for our brief feedback survey, along with access links to the webinar slides and recording. If you have questions during the webinar, please feel free to enter them in the Q&A pod at any time. That is not the chat pod. The Q&A pod is located right below the chat pod. We will have time dedicated to Q&A at the end of today's webinar. We have several upcoming ASCE webinars, and you can register for them via the links on this slide, and you can learn more about individual webinars via the ASCE course catalog. All the links on this slide are clickable, and you will receive the slides after the webinar has ended. Hello to everybody who is joining us in the chat pod from all over the place. Fantastic to have you join us today. And without further ado, I'd like to turn the webinar over to our presenter, Francisco.
Hello, everyone, and thank you for being here today. My name is Francisco Castellon, and I am a systems admin at Boise State. I have been with the university for the last 11 years, and I am one in a group of 5 individuals that provides IT support to the College of Engineering. Now, the college has been around since 1996, and it is comprised of 7 different departments. Our student base is just north of 10% of the total enrollment at the university, and it has been growing over the last few years. And this growth is really the catalyst of the initiative of how we came to implement Upstream at the college. So it all really started about 5 years ago. At that time, the forecast was for enrollment numbers to just continue to climb. So in order for the college to be able to accommodate this growth in the student base, the priority was really placed on expanding teaching spaces versus open computer lab areas for student access. So physical space was really becoming a luxury for us. And for our group, this really presented a challenge because we wanted students to maintain the same level of access to the engineering applications that were available in these open computer labs. And even though growth was steady, it wasn't significant enough from one year to the next to really warrant the cost justifications of introducing additional non-department specific open lab spaces. Now, along with that, we were becoming more and more aware of this need for students to have access to these engineering applications remotely. As I'm sure is the case with other educational institutions, we have a very diverse student population. We have folks that work part-time, others that work full-time. We have military students, excuse me, and other students that have long commutes on a regular basis to just be able to attend classes, and they don't have the flexibility in their schedules to remain on campus after their classes are done to access these computing resources. So we certainly had a need from the student side of things, and as well from faculty. Some of our engineering departments collaborate with local high schools and other organizations to put together seminars or workshops at their campuses. And from time to time, these faculty members would require access to these engineering applications that we only had available on campus. And we didn't have the, I guess, the functionality to be able to provide that type of service. Now, there's certainly technologies out there like remote desktop or VNC or TeamViewer that allow you to connect to a remote system. However, the engineering applications that we're really talking about here are have really high graphics requirements that platforms like RDP or VNC are just not well suited to be able to run these packages properly. So we obviously had this identifiable need and we were going through this growth. So we started to brainstorm on what we could do in the short term to try and field some of these requests, as well as in the long term to introduce a robust and scalable solution. So short term, we really started to take stock of the resources that we had available to us, and we allocated 40 different workstations solely for the purpose of allowing students to connect to these workstations and run the engineering applications that were installed on them. So we also used a piece of software from HP called RGS that was really good at compressing graphic demanding applications across wide area networks. So we put this together and we opened it up for students and faculty to access with the knowledge that it really wasn't meant to be a long-term solution. And part of the reason for this was because if we wanted to add an additional 5, 10, or 15 seats to this platform, we would need the space to store these systems, which we were already running out of. And we would also incur the hidden costs that go into setting up or hosting a platform like this, such as we would need the power to be able to run these systems, the network to connect them, and if necessary, the AC to cool them. So it just didn't scale very well. The RGS software was really good at facilitating remote access for students to these graphic demanding applications, but we had to use third-party software to act as a broker for these incoming student connections to these 40 different systems. So this really introduced a level of additional configuration and complexity for us, as well as from the student side of things. Unfortunately, in order for students to be able to connect to these systems, it just wasn't a very straightforward process, and there was a few different hoops that they had to jump through. And at that time, the RGS system itself or software and the broker software as well weren't they only supported Windows based clients, so there was no support for anything along the lines of Mac based systems. Now after looking at this, for us the unintended benefit really of setting up a short-term solution like this was that we got a lot of feedback from students on regards to what they liked about the system, what they didn't like, and what kind of features or functionality they were expecting from a service like this. So we gathered this feedback along with our learning lessons in setting up this type of environment, and we started to shape what we wanted that ideal long-term solution to look like. We knew that we wanted to maintain that type of mobile anywhere, anytime access, and that we also wanted to make these resources available to more than just Windows-based devices. And some of the surveys that we have sent out to our students in previous semesters that are currently using our AppStream platform, we have learned that close to 40% of the students that are accessing these systems are using Mac-based computers. So we had certainly gone down the road previously of making virtualization software for students, such as even the Windows operating system, um, available to these students free of charge so that they could configure the virtualization environment on their Macs to run these engineering packages or to be able to connect these resources. But that is a lot to have to expect from students when they just really want to get their work done. So we knew that we wanted this ideal solution to be as OS agnostic as possible and to just really make that process of connecting to these resources more straightforward than it had been for them in the past. Costs were obviously very important, and we were really looking at this from two different aspects. We obviously wanted to test whatever this platform was going to be to ensure that it met our needs and our requirements. But we didn't want to become overly committed financially in the process of doing so, so much so that it would drive our decision into long-term adoption of as a long-term solution. And at the same time, we knew that if we decided to host the solution and build it ourselves from scratch and run it in our own network, that there were going to be sizable costs, but we didn't want these costs to repeat each time that we wanted to increase capacity. So we wanted the system to scale well in regards of usage and as well as expenditures. On regards to metrics of or setting metrics of success or standards for what kind of applications we wanted to make available to students on this ideal platform, we selected the application that we thought was going to give us the biggest challenge as a test case. So for us, that is SolidWorks. For those of you that are not familiar with the SolidWorks package, it is a computer-aided design software that has really high graphics requirements. So we figured that if we can run SolidWorks in this platform, that we should be able to run all other engineering applications without much of a hassle. So really down this road we went to see what solutions were available out there, and we found out that there was really two options to choose from. We could leverage an existing cloud-based solution that already provided this functionality, such as Amazon AppStream, or we could build all or purchase all of this hardware and all of these different components, the software and the licensing, and run that and put it together in our own environment. The nice thing about the period of time when we were going through this was that we came to find out that we weren't the only educational institutions that was going through this. There was other College of Engineering, as a matter of fact, that had gone through the same process, and some of them that had already chosen their own solutions to try and solve this problem. So we figured we'd stand on shoulders of these giants to take a look down the horizon and see what their learning lessons had been and what their implemented solutions were. And we came across two specific cases. One from Cornell University that had chosen to use Amazon AppStream to do just this, the same thing that we were trying to do, and another from another educational institution that had gone the other way and had chosen to buy the hardware, buy the software, build the entire system themselves, and use VMware virtualization tools to run it on their own network. So in the process of trying to decide where we were going to start or what solution we were going to use, we really found a certain level of comfort in having a tangible or physical asset to show for when making an investment or potentially making an investment in a solution like this. Couple that with the fact that implementation of a cloud-based solution in a production environment was not quite mainstream, at least for us just at that time, we decided to build a solution ourselves and put it together and host it in our own campus network. And so we did. We collaborated with Dell, NVIDIA, and VMware to put together a proof of concept virtual lab that would allow 10 concurrent users to run SolidWorks off of Dell servers leveraging NVIDIA GPU cards, all being brokered and virtualized through VMware Horizon View. Now, when we put this test environment together and we made it available to a selected group of users, we got really good feedback from them on regards to at least compared to what our interim solution was. They were able to connect to these resources in a much easier fashion. It was really only a thin client install that they had to go through. and they were able to run the SolidWorks software without many problems at all. So it seemed like it was certainly moving in the right direction. We at that time weren't able to test the Mac client installation on in this platform, but it was certainly something that was either available or it was becoming available sometime soon. So should we have decided to implement this platform as a long-term solution, we would have been able to reach that part of our student population. However, from the IT side of things, we did run into some challenges. So at that time, this technology was, well, it was fairly new and it was very exciting because it was rapidly changing and it certainly had a lot of potential. But because of that, there was high levels of codependency between some of the components. So for instance, the NVIDIA cards need a very specific Dell servers in order for them to run, and the version of VMware Horizon View that introduced support for these Tesla and Grid cars was just being released that summer. So this platform just wasn't as stable as we would have liked, and there was quite a bit of learning as we went because of it. And part of this learning was really the figuring out the costs. Excuse me. Excuse me. Since the life cycle of some of these components that were being released were they were relatively short because the technology was moving so fast, and the vendors, I think, were trying to really fine tune their licensing structure to match the components themselves as well as the consumer use cases. We found that it was a challenge in and of itself to really just estimate the pricing with a high degree of certainty, especially when it came to licensing. So this table really was our attempt at that time to try and quantify what our cost would have been that first year should we have become fully invested in this platform versus a cloud hosted solution like AppStream. Now, when we were putting together these numbers, we found out that since we had to build the underlying foundation to support multiple users, the costs of adding more than our 10 user target up to the infrastructure's limit of 30 were really not that much more, which was nice since it gave us some flexibility to grow, but that also told us that if we wanted to increase that capacity to say 35 or 40 users, that we would be looking for at cost close to that $40,000 mark, as well as the ongoing maintenance costs for the support for the hardware or the software renewals. So it was really a case that um, when we looked at all of this, and given how fast the technology was moving then, and the short support life cycle of some of these components, we were just hesitant to spend building a platform that could potentially become out of support or relatively obsolete within one or two budgeting cycles. So, although this was really a win, at least compared to our interim solution from our end users or from our students' perspective, from our side, we didn't feel that was the case. And we decided to go back to the drawing board and take a closer look at the Amazon AppStream service. So for those of you that are not familiar with AppStream, the service allows Windows desktop applications to run in the cloud and to stream those applications to pretty much any device out there. From the get-go, we really liked the non-committal part of the costs, that we didn't have to buy the hardware or the licensing of the software or really have to worry about how the configuration or the service itself ran. AppStream has a very simple cost structure. It has an hourly price. So we knew that if we used the service X number of hours in a given month, that we could accurately estimate or close enough to what our costs were going to be come the end of the month. Now, in addition to that, the Amazon environment that allows Upstream to run offers a free tier of resources for most of their services. So this really allowed us to become familiar with the AWS ecosystem. We were able to build the test environment and really ultimately test out the Upstream service itself to see if the solution would work before we fully committed to it. So in other words, we didn't have to pay to learn to use the service. We were able to gradually introduce the paid tier resources to grow our environment from development to test over to production without fully committing to it all at once. So if at any point during that process we found that something did not align with our requirements, well, then we didn't really have much skin in the game, so we could have looked for a more suitable solution. But obviously, that wasn't the case. And we had the flexibility to scale resources vertically as needed without incurring large expenditures. So it was very convenient and still is to easily allocate high amounts of computing power to our students' Upstream sessions. It was so convenient, in fact, that we realized that it was easy to overspend by over allocating resources and incurring unnecessary costs. And one of our main questions that we had as we were going through this testing of Upstream was how we were going to be charged for those resources that were not being used all the time. So what we found out though was that Upstream allows us to define the level of accessibility or availability for these resources. So for instance, we can categorize Upstream sessions as being available on demand or always on. The equivalent of an always on application would be the same as a student walking up to a physical computer that is already turned on, logging in and getting to their desktop to run their applications. So a matter of seconds versus an on-demand resource where the student walks up to the same computer, but this time they have to turn it on, wait for the computer to boot up, load the login screen, log in, and then get to their desktop to run the application. So from the student side of things, the difference is obviously time. From our side of things, we are able to make these resources as accessible as possible. So we can certainly make SolidWorks, for instance, easily available to students to log in at any time, and they don't really have to wait too much to load the application. But we're also paying for when the application is the services themselves are not being used, just because they're always available. However, with an on-demand resource, what we're doing is we're just telling Amazon that we want to make a reservation for an X number of resources in case students connect. And in the process of making that reservation, we really are just incurring a fraction of the cost of the always-on resource. And we don't incur the full cost until a student is actually logging in and using the application. So in our implementation, we have really leveraged the on-demand functionality of these resources since we were expecting students to access the service when they were at home, after hours, evenings, or weekends, and they could easily afford to wait about a minute or so for the resources to load up. And then the use of those Upstream applications would be no different than always on resources. So another way that we also saw that we could leverage the native functionality of the Upstream environment to better allocate resources was by having the option to assign the right hardware to the right applications being used by a specific group of students. So normally our approach to purchasing hardware for a physical lab is to buy a workstation that is able to easily run the most demanding applications that will be used in that lab. So this normally means that we may spend anywhere from $1,000 to $2,000 per workstation in that lab so that a student can walk in and be able to run SolidWorks, MATLAB, ANSYS without any problem whatsoever. But there's nothing to say that a good percentage of the time students are using applications that are not leveraging the full capabilities of of that workstation. Well, with AppStream, what we can do is group our applications based on their hardware requirements. So, for instance, if I have a group of civil engineering students that may be using AutoCAD or Civil 3D, which require a lot of memory and high-end graphics cards to run properly, then I can allocate the, the necessary hardware that will allow them to do so that may be more expensive than the students that are running less hardware demanding applications. So essentially, I'm not providing a blanket hardware solution for all applications and all students. We can better tailor the allocation of our resources according to the need and save costs in the process of doing so. Now, from the student side of things, on regards to what they need to be able to access their resources, the requirements were a lot less than what we were used to. So there's no client that they need to install. They really just need a solid and reliable internet connection and a web browser that supports HTML 5.0. So this means using Google Chrome or Safari or Firefox or Microsoft Edge. So it's really nice because there's no hardware requirements from the student side of things, since the onus of the computing power is placed on the remote AppStream session. And since this is all browser based, it really opens up the door to more than just Windows systems to be able to access these resources. So Chromebooks, Macs, and even Linux systems can access these AppStream applications that we publish. So after we had some time in during the summer of 2018 to become familiar with the AppStream service itself, we decided to put together a pilot program and open it up for the fall of 2018 to a group of students or selected students and faculty members. The students that we targeted were part of our new products development lab. It's a student design lab that uses SolidWorks along with other software to produce 3D printed prototypes. And the faculty members that we reached out to were in the mechanical engineering department, where they use SolidWorks in their curriculum pretty heavily. So we went through the process of showing these folks how to access the service, how to log in, and how to run the applications, and really introduce the service as an additional resource that they could use from home or when they were off the campus network. It really wasn't meant to replace the current workflow, but to add to it. And throughout that semester, we gathered feedback from them and we followed up with them on a regular basis to see what their use of the service, how it was going, and to understand how they were using the service itself. And this is really where we started to fine tune our implementation of AppStream based on this feedback. Up to this point, we have been focused on getting SolidWorks to run properly, that we were reminded about the details that make the user experience much more intuitive, such as ensuring that when they connected to these remote AppStream sessions, that they had access to their network drives, that their authentication credentials used to access the service were the same as their university credentials, showing them how to transfer files from their systems to the remote AppStream sessions. So all of these things that really complete the experience for the user. And so after we got this feedback and we kind of fine-tuned our implementation, we knew that we needed more feedback from a larger group. So we opened up access to the service in the spring of 2019 to a single mechanical engineering class with multiple sections that was using SolidWorks pretty heavily. And we marketed the use of the service as an extra resource that they could use remotely in addition to the current interim solution that we had in place. And the same thing, we monitor access to the application, and at the end of the semester, we send surveys to the students and faculty to get their input on their experiences. And a lot of the feedback that we received at the end of that semester from the students was around the benefits of not having to have a high-end laptop to run the student versions of SolidWorks, since that was made available to students that were running Windows systems. And we also get feedback from those students that were using Macs, telling us that the use of the AppStream service has simplified the whole process of running SolidWorks, since they no longer have to go through that whole virtualization um, process of using VM Fusion and Windows to get access to the remote service, or at least the student version of the application. So we thought it was pretty cool to be able to make a Windows native application available in other platforms without having to do any client installation or configuration on the student's end. So based on all of this feedback and the changes that we made in our implementation, we decided to open up the service in the fall of 2019 to a total of 6 classes using 8 different applications. Now, most of our use cases at that time were around using the on-demand resources of app streams, where students were accessing the software after hours or during weekends from home. However, we did test the always-on resource in a material science engineering class, where previously students were required to bring in their own laptops and install a piece of software that allowed students to follow along with the instructor. Well, for the fall of 2019, we instead made that application available to students via the AppStream service. And this really allowed us to see how the service itself scaled when we had a large number of students connecting all at once. So it helped us to better understand how AppStream behaved in these circumstances, and to adjust our automatic allocation of resources to keep up with demand in these types of situations. Now, along this year, during all this time, the AppStream service itself had continued to add more functionality and features, obviously without additional cost to us. And some of those features we really started using quite a bit to improve the students' experience. For instance, we enabled the use of home folders and persistent application settings that allowed us to give students access to, or the ability to save data and to have that data available across multiple AppStream sessions. So it was almost, well, it wasn't almost, it was actually an S3 bucket that students can save their data to, and it makes it available across multiple or future AppStream sessions. So for those applications that allow customization of the interface, such as SolidWorks, where you can have different toolboxes and move around your menus, students were able to keep that same configuration in their future sessions. We used the reporting capabilities of the AppStream service as well quite a bit. As a matter of fact, we were able to use 2 additional services, AWS Glue and Amazon Athena, to really show us what students were connecting to the service, how long they were connecting for, what applications they were running, and we were able to essentially massage this data to produce meaningful reports that allowed us to see what applications were being used the most and which ones are not being used at all. It really helped us to understand some usage patterns that we could leverage to better forecast the resources as well as to go back to the college or the individual departments to give them accurate information on how their students were using the service and how often. So it gave us a quantifiable way to show the benefits of using AppStream at the college. And based on this usage information, as well as the usage information that we had access to for our interim solution, we decided at the end of this term to decommission our use of our interim solution so that we were only going to be using AppStream from that point on to allow students to access the engineering applications that we were making available for them. Now, at the beginning of this year, there was one feature in particular that AppStream added on called desktop mode that facilitated the interaction or how students interacted with the remote AppStream session. Up to this point, AppStream had really just given students direct access to the application. So they didn't really have access to their desktop. But with the introduction of desktop mode, students can really see the full, essentially the full remote system. So they have a desktop, they can access the start menu to run additional applications. It's easier for them to navigate to their home folders or to their network drives. So it really enhanced the functionality of students on what they were able to do when they connected to the remote sessions. When COVID hit at the beginning of this year, since we already had um, the foundation for AppStream running and the infrastructure working properly, it made it very straightforward for us to move those courses that needed to go to an online offering and to bring along the applications that those courses require their students to have access to onto the AppStream platform. So we had established a good process to test the applications in the AppStream platform, ensure that we were able to run it without issues, and give students access to it. We used AWS SSO, which allowed us to better target which applications were assigned to what users without having users to have to go to a different place to log in to access these applications. So essentially, all of our students go to one single place to log in, and when they log in, they get presented with the list of applications that they have access to. At the beginning of this semester, we obviously are seeing a lot more usage of the service as we have in the past. And these numbers themselves have actually changed since the beginning of that semester. But we have just over 500 students that are signed up to use the service and 15 different classes that are using 20 different applications. Right now, really what we're focusing on is trying to forecast as accurately as we can what usage is going to be so that we can make just the right number of resources available to students. And although I feel that we have a very strong implementation of the AppStream service right now, there's certainly a lot of learning lessons that we have gathered along the way, and still right now with this forecasting of how many resources we should make available. So, if I can really impart some of these learning lessons and you're considering adopting this type of platform in your environment, I would start by telling you that um, students really just want stuff to work. They don't really care how fancy it is or what has to happen behind the scenes. And normally, when they just want stuff to work, it means that they just want things to be able to do things in the same way that they always have. And if that changes, then that change has to make it easier or much more convenient for them. What that means for us is that we were really um, we wanted to keep the implementation of the service as close as possible as to the user experience that they would have if they were logging into one of the computers here on campus. So ensuring that they have access to their network drives, that they have access to all the applications that they would need to be able to get their work done for that specific class that access was requested for, that they use the same credentials as they use at on the university computers. So really, everything that makes that experience for them as familiar as possible, as if they were logging into one of the computers here on campus. Faculty for us were really key in driving the implementation of the platform. They were really the ones that helped us to find out if adding a particular application onto the platform was going to bring value or not. And when we made a decision to add an application, to see if there was other applications that would also prove beneficial for that same class to have access to, as well as getting information from them in regards to what they think usage is going to be throughout the semester. So if they have, say, an assignment due at the end of the week and they expect students to be working late on that assignment, so they can let us know and we can ensure that if we're expecting above average usage, that we can make those resources available for them. We have a fairly standard process now of onboarding applications into the platform, and really one of our first steps is to follow up with the software vendor to ensure that our licensing allows us to run the application in a cloud environment, as well as that the licensing model itself plays nice with virtualized resources. Before the fall of 2019, when we made the service available to more than just one class, we created an online knowledge base that essentially described to students what the upstream service was, why we were using it, how to use it, and it provided them with a handful of how-to video resources to walk them through how to log into the service, how to get access to their network drives, how to get around the upstream menu, how to transfer files from their computer to the remote session. So we have really made this part of the process when we give access to new students, so that it essentially answers those questions for them from the get-go. And ultimately, gathering feedback is really important. It has been a very crucial step for us in the way that it has driven the implementation of the service. So it has helped us to learn what applications students would really benefit from having access in the service, how often they use the service, and to really understand their needs as well. So this is where we got some of the data that told us how many of our students were using Macs versus Windows systems. So really outline how important having access to a service like this was, and along with driving our implementation of the service, also letting us know how valuable the use of the service in the college was, and if it was well, moving in the right direction in a sense. So, but this is all I have. So I'm going to pass it over to Alex.
Thanks, Francisco. So we have Greg Ritter with Amazon Web Services on the webinar right now, and Greg and Francisco are going to answer some of your questions.
Thanks, Alex. This is Greg. Thank you, everyone, for joining today. I've been answering some of the questions in the Q&A pod here in the webinar interface, but there's some questions that I want to pass along to Francisco to answer. Francisco, you ready to take on some questions?
Sure.
So we've gotten several questions about software. You used SolidWorks as an example, but could you describe some of the other software packages that your College of Engineering is using along with AppStream?
Sure. Well, SolidWorks, like I said, was the benchmark for us. A lot of the Autodesk software as well. So AutoCAD, Civil 3D, Navisworks. Let's see what else. Revit. We are also using CES EduPack. We have Silinks available in there as well. Let's see what else. There's a new package that we're just in the process of bringing onto the platform as well. It's called Stella Civil Engineering Package. I see some questions in regard to USB pass-through. We haven't really used a package that needed that functionality just yet. Although I believe that there is a version or there is an actual client for AppStream that you can install, so it's not browser-based, that gives you extended functionality. And I think that some of that, and I'm quoting this from memory, we don't actually use the client, but from what I have read, the client itself gives you the functionality to use multiple monitors or dual monitors, and to also use USB pass-through, if I'm not mistaken. So that's an option that you can make available when testing your own environments if that's one of your requirements.
That's correct, and it's worth noting too that is a Windows-only client. We don't support the native client for other platforms right now, although of course the browser access is available from pretty much any device. So another question that has come up a lot, and for the folks in the webinar, the participants, I'm trying to aggregate some of these questions together here. We will take the questions offline and respond to you directly if we can't get to all of them in the session today. There have been several questions about license management, particularly about how you have implemented the license management, and did you use a license management server? So Francisco, could you talk a little bit about the license management experience with AppStream at Boise State?
Sure. So we didn't really want to recreate the wheel on regards to having a license manager on campus and then having a license manager on the AWS cloud. So what we did was we just established a secure connection from our AWS virtual private cloud to our on-campus network that only allowed the traffic for those specified licensing requests. So when an AppStream session comes up, it pulls from the same pool of licenses that we have available on campus. So for instance, for SolidWorks, if we're only, or MATLAB, let's say, if we're only licensed for, let's say, 50 clients in the entire university, then whether a student is using the software via AppStream or on campus, those licenses are being pulled from the same licensing server. So we're still respecting the licenses that we have received from Simulant or from MATLAB.
Great, thanks. There were a number of questions on both accessing files and saving files. Now I know at Boise State, implementing the new desktop mode helped you guys a lot with that. Could you talk a little bit about the process for an end user working with files both before and after you implemented the desktop mode?
Sure. So certainly before, it wasn't a very straightforward process. It was, what it required users to do was, if you can imagine looking at Microsoft Word in front of you and clicking the file button and then going to open, and then you're listed with the directory structure of the computer. That's essentially how users had to save and access files directly from the application, since they didn't have access to Windows Explorer. With the introduction of desktop mode, now the users can minimize the application and just go to their desktop and run the My Computer icon and be able to access or see their network drives, or like I said, their home folders, to access the files or the paths that they want to get access to. So it has certainly eased the process of doing that. Part of the reason why we created the how-to videos was because there was a lot of questions on that regard from the student side of things, on how do I access my C drive, or how do I access my, we call it our W drive, how do I access my W drive. So, but since we enable desktop mode, the process is a lot more seamless. It's essentially the same as they would have here on the campus computer.
Great. So one of the areas of interest that a few people mentioned was the amount of effort. So Jeremy Gomez asked what type of IT resources will be needed to implement and maintain this. Mark Easley was asking how easy is it to drop in AppStream into an existing environment, particularly with firewalls and whatnot. So can you talk a little bit about the level of effort that your team at Boise State experienced when implementing this and maintaining this in an ongoing fashion?
Yeah, you know, I think that we certainly benefited from the gradual introduction of the service in our environment. So we didn't just really take it all in at once, and we really just targeted a small group of users so that we could get their feedback based on whether we were missing something in our implementation or not. Initially, the service itself, if I'm not mistaken, correct me if I'm wrong, Greg, but I believe that there is a way that you can go through on the Amazon website and start publishing an application from the get-go, and it builds the underlying infrastructure. So it builds the VPC for you to start running this application. So it was certainly, there was a lot of research that we had to do, because I knew what we wanted in regards to, for instance, the licensing. I knew that that was going to be a question that we were going to have down the road, how that was going to work. So taking the time to understand that process really paid dividends for us, I think. And there's a lot of documentation out there, and this is a very well documented process. As a matter of fact, I think that there are step-by-step guides on the Amazon site in regards to how to add MATLAB to AppStream, and it walks you through the whole process of creating the subnet on the VPC, and creating your clients, and defining your fleets and your stacks, and all of that technical stuff that does take quite a bit of time to test. But like I said, you can really leverage a lot of the free tier services before really fully committing to this, and just learning along the way. So
Terrific. Thanks for that. So sort of following up on that, there were a couple of questions about the process for setting up a new app, or how difficult it is to configure the image for a new app that you want to add into this.
Yeah, now that we have everything, the foundation running the way that we want it to run, really I think the bottleneck for us is just our process of getting the right information from faculty and the software vendor to ensure that we can run the software in the platform properly. So it's not so much a matter of can we make it run, but more of a should we make it available in the platform type of question. I think that usually by looking at the software itself, usually for us, licensing is what really drives whether we're going to be able to put the application on the platform. So for instance, in a floating license model like MATLAB, it's fairly easy since the licenses are not tied to a MAC address or a disk ID on the machine. But on those applications where the licensing is node-based, it's not impossible, but we have really had to work with the vendor in order to try and work those issues out. So bringing the application onto the platform is very straightforward. So from a maintenance perspective, it's no different than, it's actually much easier than building images for our computing labs, because I can easily, I already have an image that I use for the different departments in the college that have certain applications for each of those departments. So when a department requests a new image, it's just a matter of spinning up that image, making a change, adding that application, and publishing it to the students that are using it. So the change is very minimal from our side of things. It really is just a process of testing it and ensuring that we should be running the application in the platform.
Great, thank you. And another question about the end user experience. How much broadband does the student need to be able to use this effectively? Have you encountered issues with students who don't have sufficient bandwidth to be able to access the applications you're streaming to them?
Have we encountered that problem? Yes, definitely. There is usually a couple of users here and there that I would correspond back on a regular basis to, that they're having problems, that the connection drops on them or whatnot. But you know, it's really hard to say how much bandwidth. Now I'll tell you, I'll speak from my own experience. I don't have a really high connection at home. I think that I have just less than 10 megabit connection there, and when I test the applications, when I install them in the university and I go back home and I test it from my place, I haven't encountered any issues in regards to my connections being dropped or anything of that sort. It really is more, I can tell the difference in regards to a on-demand resource versus an always-on resource, that it usually takes me longer to wait for that resource to become available, or at least to load up on my home machine, than it does obviously here in the university network. So from that side of things, I have gone through the process with some of these students that have network problems to try and troubleshoot as much as I can remotely, and figure out if it's a case that they may be streaming a lot of Netflix or Amazon Prime movies while they're trying to connect to the service itself. But I really haven't had any issues of a group of users telling me we can't access these systems. For us, one of the learning lessons in the beginning was that when users were having problems or the application was taking too long to run, then it was that assignment of the right hardware that was dedicated to the remote app stream session that we had to increase. So that definitely makes a difference in regards to response time, or having simulations run just as fast as they do on campus systems.
Right.
So, yeah.
So one last question for you, Francisco, and I promised you I wouldn't throw you any hardballs, but this one might be a little bit of a hardball. How did you convince the administration to go from a capital expenditure model where you were, doing that capital outlay for the on-prem implementation to the more OpEx model of paying as you go for the cloud? Or was that even a challenge at Boise State?
Not really, not for us. Our administration, our dean, has actually been very supportive of this process from the moment that we brought it up to their attention. I mean, when you're presenting something and saying, hey, this is going to cost me $45,000 to set up, versus this that is not really going to maybe just cost me a few $100s, which way should we go? So it wasn't really a hard sell from that perspective. And as well from I mean, really showing that we had done a research in regards to if we knew that this was going to take off, and we certainly hadn't predicted this happening this year, but if we knew that this was going to be really well received, that our concern was, a valid concern was that if we became overly committed in expenditures in a hosted solution and it didn't work, then we would be sitting with tens of thousands of dollars worth of equipment that we would have to reallocate to something else because this initiative didn't work, as opposed to just saying, you know, this may cost us a few $1,000s to really get off the ground and to test it, put it through its phases, and if it doesn't work, we can move to something else. So from a
Great
cost side
point.
of things, I think that it was a good sale. So
Great point. Well, we are at the top of the hour, so I want to thank all of our participants for joining us today, and especially thank Francisco for the presentation. Alex, I will turn it back over to you for any last comments.
Thank you, Greg. Thanks, Francisco. Thank you, everybody, for attending this webinar today. We hope you enjoyed it. I think you did from your engagement in the chat pod and the Q&A. In a little bit, you'll receive an email with a brief feedback survey and the webinar materials, which include the slides and the recording. And that's about it for me. So thank you so much to Amazon Web Services and, of course, Francisco for this fantastic webinar and helping us learn more about AppStream. And thanks again, everybody, for attending today. Have a great afternoon. Okay, to our presenters, we have stopped recording. And